Continuing where we left off, we're talking about what happens with q and q prime, which are rational or irrational numbers. And since we can't really list only rationals or only irrationals, when it comes to questions like this, the best part is we can't do them. Okay? So we just cancel these questions. There is no way to specify only those rational or irrational numbers. So we can skip that whole section. Okay. Now, so you can cross those all off on your page. So when it comes to these, the last little bit that I wanted to mention, okay, so now that we know how to do real numbers, integers, and whole numbers, is some of the definitions, which I kind of have been hinting at as we go. What is a discrete set? A discrete set is a bunch of discontinuous values, as I mentioned, like the frog jumping on the lily pads. And that's what happens when we're talking about n or z, okay? When we're graphing it, they're a bunch of separate numbers. A continuous set is used for the real numbers, and that's when we have all of the values that are included between two amounts. Okay, so it's continuous. We can actually just drag a line through them all like a snake would through the grass. A line segment. This is going back to grade 7 geometry, which we probably skipped because of COVID, but a line segment basically has a beginning point and an end point. And that's where we put the solid dots on either end. A ray is where it has a starting point, but no ending point. So on a line, a number line, it could be pointing to the right, or it could be pointing to the left, depending on whether we're using a greater than or a less than kind of situation. And the interval, the part that I really want to emphasize here is that we only use interval notations for real numbers. Otherwise, we make a list, okay, for the values. So all of these questions that you see down here with the square brackets, those are for real numbers only. So commonly used symbols, I can go through this quickly, okay? This says x greater than 9, okay? You could say x is greater than 9. And the next one says x is less than 9. So this was also on the MHS video. The next one with the little line underneath says x is greater than or equal to 9. And the other one says x is less than or equal to 9. Now, you can just tell from the amount of writing that it takes that the symbolic notation is a lot more concise, right? It takes a lot less space and a lot less time. Whenever you see a sandwich inequality, I prefer that you try to use the words from and to or the word between, because the x is always going to be situated in the middle, like the meat in a sandwich, and the 4 and the 9 are the pieces of bread. So when I read this, this says x is between 4 and 9. But then extra little part that we have to add to this is that x could also be equal to 9 and equal or equal to 9. And I'm supposed to use the word or. And this other symbol with the equal sign and a line through it, what do you think it means? Not equal to. So this basically says x is not equal to 9. So the word that we use for that is 9 is excluded, okay, from this set. So I could take a long time to do this. I'm not actually going to write it because it's going to take longer than the actual symbol. I'm just going to say it. So when I'm talking about this symbol, this says all of the values from 3 to 8. The next one says all of the values from 3 up to but not including 8. The next one says all of the values not including 3, okay, so greater than 3 and less than or equal to 8. Or I could also say between 3 and 8, including the 8. And then the last one says between 3 and 8. We are not including either of those endpoints. Now the last 4, this is where it shows whether you understand what's really going on. When I say the interval from negative infinity to 2, this is the same statement as x is less than 2. As soon as you understand that interpretation, then you're on your way to understanding this really well. When it comes to the next one, this is saying from 2 up to positive infinity. So the other way of writing that is x is greater than or equal to 2. How come I'm saying equal to? Well, because the square bracket is turned toward the number 2. The next question, very similar to the one above it, except this is saying that the x is less than or equal to 2, right? Because I'm including the 2 in that square bracket. And the final one, x is going from 2 to positive infinity, but not including the 2 because of that square bracket. So it just means x is greater than 2. So hopefully this all makes sense to you. And you just have to finish off the rest of the homework, which was pages 19, 20, and 21, which is more practice going through the same sets of examples and the different notations that we might use. The only other thing, actually, I'm just noticing this right now, I'll do 21, letter E, because it talks about set builder notation. And set builder notation has that extra little detail about what set of numbers we're talking about. So question E, it says show the following interval negative infinity to 5 to negative 5 in graphic notation and in set builder notation. Right away, you're asking yourself, is this going to be reals, integers, or whole numbers? Okay? And how do we know that it's reals? Because of the interval notation. Only real number lines have interval notation. So this is saying from negative infinity up to negative 5, and we're including the negative 5, so I'll put a solid dot at the negative 5, and it's saying from negative infinity, even though the arrow points to negative infinity. And when I'm putting together the set builder notation for this, it means that it's the x belonging to the real numbers. And you should have seen this in the MHS video. We put a vertical line here, which is the phrase such that, or according to the following rule. And in this case, the rule is, how do I describe that as an inequality? X less than or equal to negative 5. So that's how we build our set builder notation on those types of questions. While you're doing page 20 and 21, you're going to encounter that. All right, good luck with all this work.